Hi friends, welcome to Unit 3, Day 7 notes. This one talks about polynomial and rational inequalities. This kind of sums together everything about what we were talking with inequalities, polynomial inequalities, rational inequalities. We've been looking mostly at equations and how they look graphically. Now we're going to be looking at inequalities. To solve quadratic inequalities, so we're going to start with just quadratic inequalities first. We have to locate the real zeros of the function. So to do this, going back to what we've done previously, this is where we solve the quadratic first. And then you can use any techniques that you have to solve the quadratics. You can do it by factoring, using the zero product property, square roots, quadratic formula, completing the square, whichever one you feel most comfortable with, and you have the resources to do. And then you have to determine whether the graph opens upward or downward. If it opens, we use that to essentially find out where the spots in the graph are greater than 0, less than 0, and then greater than or equal to, and less than or equal to. And then the last thing to note is if there are no X intercepts. So when you solve and you get no solutions, then you have to think about that the graph is either entirely above the x-axis, so all your y values are positive, or the graph is entirely below the x-axis, all the y values are negative. And what I mean by this, if I have a graph, and then I have a quadratic on the graph, and the quadratic is like this, well, all of the values for this particular graph, all the y values are positive. All the y values are positive. Similarly, if I have a graph like this, then we have all the y values are negative. Which is good to know as we move forward. Example 1, here I have f of x equals x squared plus x minus 6, and I want to know when f of x is greater than 0. So what I'm going to do first is I'm going to go ahead and factor x squared plus x minus 6, because that's one that we've factored often actually for this class. So I have f of x equals, this one is x plus 3, and then x minus 2. And I want to know when the values of y are going to be greater than 0. So what I want to know is essentially when f of x is going to be greater than these zeros on the graph. So it's going to be greater than x plus 3 and x minus 2. Think about this graphically. So if I have a graph, and then, let's see, I put my zeros at 2, and then at negative 3. Think about what's happening on this graph. This graph is going to open upward. So if I think about all of my values, this actually will come down here. And I'm going to kind of extend this off a bit too. So on this graph, when does this graph have values that are greater than 0? If I look at it, visually I can see it's when my x values are going to be less than 3. When my x values are less than 3, then it's going to be greater than 0. And then my x values are greater than 2, it's going to be greater than 0 for my y values. And here you can visually see all of these values between negative 3 and 2 are going to be less than 0. I'm going to have a y value that's negative. So for here, when I'm greater than 0, f of x is greater than 0 when, so here, x is less than negative 3, or x is greater than 2. And then we have different ways we could write that. I can write it in interval notation from negative infinity to negative 3 non-inclusive, union 2 to infinity non-inclusive. I could do set notation. The set of x's such that x is less than or equal to negative 3, or x is greater than 2, and so forth. So just kind of highlighting that. The best way to solve these after you factor it is to visualize what's going to happen on the graph when it's going to be above or below using the techniques that we've discussed already. For this next one, solve this inequality. So here I'm actually saying negative x squared plus 6x is less than or equal to 9. Here I'm going to move everything over to one side. So I'm going to subtract 9 from both sides. So this gives me negative x squared plus 6x minus 9 is less than or equal to 0. Now if I factor this, I'm going to have an issue with this negative x squared. So if I change the signs on everything, so if I factor out a negative, and I have x squared minus 6x plus 9, now I have something that I can factor quite easily. This is actually x minus 3 quantity squared is less than or equal to 0. So now if I think about this on the graph, because of this negative sign, that means it's going to open downward, and I only have one solution. It has a multiplicity of 2, so it's going to bounce there, which we know. Again, going back to my graph, and I know it opens downward at 3. So here, that's 3. I know it opens downward. So I want to know, when is this graph going to be less than, have y values that are less than or equal to 0? And if I look on my graph here, I can see this is the y value where it's at 0, and I don't go anywhere above that point. So if I think about my y values, all of my y values on this graph are going to be less than or equal to 0. When it's 3, it actually is 0, but all these other values, it's going to come out to be less than 0 as well. So this is a situation where we have all real numbers. So this, if you write it as interval notation, remember it's negative infinity to infinity, or the set of x such that x is an element of the real numbers. So we're talking about interval notation, set notation, and then this is the graph to represent this. Remember, we're graphing inequalities. This is a very quick sketch of the graph, visually what's happening, so it's good to know just kind of overall what's going on here. Join me in the next video as we get into polynomial inequalities.